Hi guys, we're going to be looking at the next part of the log stuff when we're doing derivatives. Alright, so I'm going to have a look at question 4. Now question 4 asks you to basically differentiate something by using logs first. It's really the only way you can actually do it, so that should make sense. So let's do one or two of these. I might do B first and then we'll do something like question F. Alright, so and it's really is using a log law. So question B, so 4b, so if we're looking at that, we've got the function y equals 2x. Now I could say to you, how do you derive that? And you don't have the skills to be able to do that because you can't. Alright, so what we're going to do here is we're going to take the log of both sides, so ln of y equals ln of 2 to the x. Now the rules of ln means that I can bring that down, so I can write that as ln of y equals x ln of 2. Alright, now ln of 2 is just simply a number. You can just put it into your calculator and do ln of 2 and it's equal to something like 0.693. Okay, but it's much more accurate to write ln of 2. Alright, now if I derive this, okay, now I have to use my implicit differentiation here, so 1 over y would be that dy dx. Excuse my writing. That's equal to, well, x is simply going to give me ln of 2. And so therefore, if I actually want to express that in terms of dy dx, so therefore our dy dx, after times the y across the other side, so that's going to be y simply times by ln of 2. Now, we do know that y is equal to 2 to the power of x, so therefore I could say that's equal to 2 to the x ln 2, and that's my final answer. Hopefully you get the idea about that. Alright, so let's do another example. We might do the last one because that looks like a bit of a pain. Alright, so this here we've got y equals, this is f that we're doing, so we've got y equals, and I might actually do this one black because I think some people actually struggle to read red, so you just go y equals, and that's equal to x to the half. I'm going to write that as x to the half, x squared plus x cubed, and that's all over e to the 2x squared. Now obviously same sort of concept again, we're going to do the log of both sides, the ln of both sides. So when I do the ln of that, that's going to allow me to write this as ln of the top line, which is going to be x half times x squared plus x cubed, and then it'll be take ln of e to the 2x squared. Then I can say that's equal to ln. Now this is times together, so that's going to be ln of x to the half plus ln of x squared plus x cubed. Now ln and e's cancel out, so I might as well just write that as minus 2x squared, and that's what my ln of y is equal to. So ln of y is now equal to, now I can bring the power down, so I can say it's a half ln of x, bring the power down, so that's going to be plus 3 ln of x squared plus x, and then take 2x squared. Alright, so I've rearranged this in the form of ln, so now I can take the derivative. So then I can say the derivative is simply 1 over y dy dx. So half, that's going to be 1 half 1 over x, that's what the ln of x is, 1 over x, plus 3, and then that's going to be x squared plus x. Now I derive that and put on the top line 2x plus 1, and then I derive that, which becomes minus 4x. So then I can say that dy dx is equal to, well I might as well write it as 1 over 2x plus 3 lots of 2x plus 1 all over x squared plus x, take 4x. Now I need to times that all by y. So the way I can actually represent that as my final answer is to say that dy dx is equal to, now what was my original y equal to? My original y was equal to a fairly ugly looking thing. So I could say it's equal to x squared plus x to the power of 3 all over e to the 2x squared. That's my y value, and then I've got that 1 over 2x plus 3 lots of 2x plus 1 all over x squared plus x, take 4x. Okay, so I've now done the two examples where you actually have to use your ln's to actually differentiate that. Otherwise you just simply can't. Because I mean, if you think about this one up here, the reason why we couldn't really differentiate this term easily using our other laws is we now have 3 functions. We've got this function here, we've got this function here, and we have this function down the bottom. Alright, so the rules don't work for that, so you've got to use your ln's to simplify it first up. Now, have a go at question 4, finish the rest of those and see how you go with them, and catch up with me if you need some help.